So as we're looking at unit 2, this says, what is the average rate of change of this cute little parabola? Cute little parabola. And from A to B, again, these are x values. So this is saying from 1 to 3 on the x-axis, just from 1 to 3. Or from, so let's actually talk about it in terms of A to B first. You guys, average rate of change, that just means slope. You guys, how do we find slope? Slope is just the change in y over change in x. How would I do that if these x values are a and b? So like if it went from x value of a to x value of b, what we're really looking at is just f of b minus f of a all over b minus a. That's just slope in terms of my x values that are a and b. F of b is just fancy for y, right? F of a is just fancy for y, just like f of x is fancy for y. Okay, so we're just finding the slope. Now this says from 1 to 3. So if I were you on your cute little picture, I'd go from 1 and I'd put a little dot there. And then at 3, I'd also put a little dot there. And that happens to be at 1, 1 and at 3, 9 because the function is just x squared. And then you guys, let's just draw a line through there. So what would I do if my interval is from A to B, and in this case, that's 1 to 3. So what would throwing in 1 and 3 look like to this function right here, to this equation? F of 3, love it, minus f of all over. Perfect. Or you could just say 2, but I just like to say 3 minus 1. I love it. You guys, what is my function? I gave you my function here. My function is x squared. So if I'm plugging 3 into my function, what would that get me here? What would f of 3 be? Yeah, 3 squared is 9 minus, what about 1 into my function? 1 squared is 1 all over 2. Final answer, what's my slope of this line?
4.
Boom. Does this look like it's a slope of 4, up 4 over 1? I'd say so. Sure, like you said. Oh, and it's actually, the scale is even, so we could actually count it. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Yep. Okay, then this is what calculus is. You're saying, I don't want to know what my average rate of change was from 1 to 3. I want to know what my actual instantaneous rate of change is, right, at, say, 1 second. And rate of change is just that slope, which just means velocity, right? So, like, I want to know what's my slope right at 1, potentially, or right at 2, not over a time interval. So what we're going to do, being x, f of x, that's just a normal point. That's like an x comma y, right? And my next point, I'm going to add a little horizontal distance. And what would that do to my y coordinate? It's just going to be f of x plus h. And again, that h is just that little horizontal distance between the 2 points. So let's use these 2 points, again, in that same slope formula, you guys. Let's do it. What's my change in y then? What minus what? F of y minus y? X plus h minus f of x, that's just a y minus a y, all over x minus x. So we'd have x plus h minus x. So that's just me doing change in y over change in x again. Would anything cancel on the bottom here? Yeah, x minus x is gone. So you guys, what we got here, and I'm going to have you write a limit notation in front of it. The limit as h approaches 0, we want that horizontal distance to approach 0 of f of x plus h minus f of x all over h. This is how we find that instantaneous rate of change. Let's put that in motion, guys. What is the instantaneous rate of change then of this function when x is 1? So I found the average slope was 4 between 1 and 3, but I want to know the actual slope at 1. You guys, looking at the picture, do you think the actual slope will be bigger than 4 or less than 4? Less than 4, right? Is less steep? Okay, so here's what we're going to do. You guys, the function at when x is 1, then we're going to plug that into my function to get my y. And then the next point is just 1 plus h, f of 1 plus h. And I know that that's funky. And I'm just going to put what our function was. Our function was x squared, just so I can scroll this up. All right, people, we can do this. Let's go find out what f of 1 is. If f of x is x squared, what's f of 1? 1. I agree. Okay, so I'll put that there, but maybe before I even write it out, let's just plug it into our good old slope formula. Using this, we're going to do y minus y over x minus x. Let's do it. So we got f of 1 plus h minus f of 1, that's y minus y, over x minus x. And do you agree on the bottom, my 1's are going to cancel out? So off to the side, you guys, I want you to say the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h.
Why is it h approaches 0? Oh, because that's the...
Yep, because we're going back to that formal definition right here, buddy. Great question, Ritz. All right, guys, we got to plug in 1 plus h into my function. What's that going to look like when I plug in a 1 plus h right there? Don't forget, we got to keep it, I'm going to put this up here. We got to keep it in parentheses. So I'm going to say 1 plus h is squared. That's me plugging in 1 plus h into my function. Minus, and you already said it, what is plugging 1 into that function going to get me? 1 squared is 1 all over h. Okay. What is 1 plus h squared? 1 plus h times 1 plus h, and maybe you need to write that out. 1 plus h times 1 plus h. 1 plus 2h plus, love it, 1 plus 2h plus h squared. I got to bring down this minus 1, still all over h. Anything cancel out? Hey, we got 1 minus 1 cancels. What about the rest of the things? What happens? They all have an H. If everything left doesn't have an H, we got a problem. Everything has an H, so I'm going to say you're gone, and you're gone. So what am I left with? The limit as H approaches 0, what would we be left with? 2 plus?
2 plus h.
Yes, and then Coop, guess what? When you plug in that 0 right there, if h is approaching 0, what would I get for my slope? 2. Does it look, what we just found, it said what is the instantaneous rate of change when x is 1? Does it look like that slope could be 2 if my average slope was 4? Sure. Okay, let's just try one more with this. What about when x is 3? When x is 3, do we think that that slope is going to be bigger than 4 or smaller than 4? I'm going to do 3 in blue. Here's 3. I think it's going to be bigger. I think it's going to be steeper than 4. So let's go do it. Still the same function. So we're going to say, all right, we would have the limit as h approaches 0 of f of x plus 3 plus h, my bad. My x is 3, minus f of 3 all over h. This is again using that formal definition of the derivative. Y minus y over x minus x. Why did I leave out anything else on the bottom? Because they're always going to cancel, and I'll always just be left with h. People, let's do it. What am I going to get when I throw in 3 plus h into my function, which was x squared? What's 3 plus h times 3 plus h? Yeah, 9 plus 6h plus h squared. And if you can't do it in your head, no problem, people. You got to just write it out. Minus, what is f of 3 into that function? 9, that's kind of convenient. All over h. Anything canceling? 9's cancel. And then you're like, shoot, everything's at an h. Life is good. I'm left with 6 plus h. And Beck, what happens if h approaches 0? What's my slope going to be? You got it, bud. Minus f of 0 all over h. What happens when I plug in 0 plus h into my function, which was x squared?
It'd be h squared.
Yeah, 0 plus h is just h. When I plug an h in there, we would just get an h squared. I dig it, Coop. So we got h squared minus, Coop, what about plugging in a 0 right there?
That'd be 0.
That'd be 0. 0 squared is 0. All over h. Coop, anything cancel?
Yeah, the 0 and 1 h.
Agreed. So I'm just left with the limit as h approaches 0 of h. And what happens when I plug in a 0 there, bud?
0.
And we predicted that. We're skipping page 2. We're on page 3. We're talking about Kenny. Kenny's got a helicopter, guys. I don't know if he really does, but I just felt like using his name. And selected values of K of T are given in the table. The altitude of Amina's helicopter is given over here. So this one's talking about, ooh, that font is too big. This one's talking about Kenny. This one's talking about Amina. Okay? Kenny, I just gave you a table. Amina, I just gave you an equation. Then they're both measured in feet, and T is measured in minutes after takeoff. What is the average rate of change of Kenny's helicopter between 5 and 20? Average rate of change, you guys, average rate of change, that just means slope. That just means change in Y over change in X. So when AP asked you that, you're going to go back to 7th grade math. What is the change in Y over change in X from 5 to 20 of Kenny's? Check that out. They're saying use this point and use that point. What would be my change in Y over change in X there? Let's just write it out. 15,000 minus 3,500 over change in X.
20.
And you're done. Because guess what? You don't have to do an AP. Simplify. We're done. But did you happen to simplify, Harvey? What'd you get?
2,300 over 30.
Okay, and then divide that for me. You get 23.
766.46.
And it's got to be 3 decimals every time, so go ahead and do 667. Does that sound good? Which you guys wouldn't have to get. You don't have to get this because we can end right here. And look what they said, you guys. Indicate units of measure. We would have to do we would have to put the units, even if we left it like this. And you guys, since we just did change in Y over change in X, what would my units be?
Velocity.
Well, but in this context, ready?
Feet per minute.
Exactly. We did change in Y over change in X, which happened to be feet per minute. But if your answer was highlighted in my red, you'd get 100%. You don't need to simplify it. Sound good? Okay. Average rate of change of Amina's. How am I going to do that of Amina's over 5 to 20? How am I going to do it without the points? Could I get the points? Exactly. Let's go plug in 5 and let's go plug in 20. So yeah, this one is calculator active. I'm going to go find E of 5 and E of 20, plugging those into my calc. Is that what you got, Dean?
Yeah.
4225. 4225 for that one. And then if I plug in a 20 up there, I got 13,600.
Yep.
Okay, so what would be my change in Y over change in X? What minus what over what minus what? These are points. And it might help you to write it as 5, 4225, and 20, 13,600. That's what this represents a point, X, Y. So how would we write out her average slope?
13,600 25.
Thanks, bud.
All over 20 minus.
You got it. And you could write 15, but why? We might make a mistake. I would just end right there. What are her units going to be? Also feet per minute. Well said. Boom. And in case you're curious, it is 625 feet per minute. 625. So whose was going faster? Keeney's helicopter. He was going faster. Okay, the last thing I want to do is I then want to do D. It says write an expression involving a limit for the instantaneous rate of change. This is this formal definition of the derivative of Amina's helicopter at time t equals 7. They want to know how fast is she going at this one moment in time, not over this time interval. So here's what we got, people. And I want you to write a little, let me just show you how much space this used. So here we go. That average, the formal definition of the derivative, I'm going to just write it out one more time. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. That's the formal definition of the derivative. This is to find the instantaneous rate of change. At this moment, where do they want our speed? At what time?
7.
At 7. So you guys, my x is going to be replaced by a 7. Wherever you see an x, we're going to replace it with a 7. So I'm going to say, all right, the limit as h approaches 0 of f of 7 plus h minus f of 7 all over h. Whew, and her function is, it's not too bad actually, is it? Yeah, it's not too bad. Okay, so you guys, when I plug in 7 plus h into this function, I got to put a 7 plus h in for this t and for this t, bless you. So you guys, we're going to say we got the limit as h approaches 0 of negative 11, 7 plus h squared plus 900 times 7 plus h. That is me plugging in 7 plus h into my function. Then we got to subtract f of 7. So if you haven't gotten your calculator out, please get it out so that you're participating and doing this part. We got to go find f of 7. And again, that function was negative 11 x squared plus 900 x. So I'm going to go ahead and put in a 7 wherever I had an x. F of 7 I personally got was 5761. So this was f of x plus h minus f of 7 all over h. Things are going to need to cancel out or else we're going to get in trouble, but we won't know if they cancel out until we say distribute. So I'm going to go ahead and I've got negative 11. Let's distribute. What would 7 plus h times 7 plus h be? You got it. 49 plus 14 h's plus nh squared. Good. And you guys are like, oh man, I couldn't do that. Write it off to the side. Don't just take for what we're doing. Plus, go ahead and distribute this. What's 900 times 7? 6,300? Does that sound right? 9 times 7? 63. Add a 0. 2 zeros. And then we got 900h minus 5761. Ooh, this is looking ugly, but we got this, people. We got this. Using those calculators, go distribute. Negative 11 times 49. What'd you all get with that part? Negative.
539.
Thanks, Mar. 539. Mar, negative 11 times 14.
Negative 154.
Agreed. Minus 154h minus 11h squared. And then before I just write the rest, I'm actually going to combine these two. I'm going to say what's 6,300 minus 5761. Oops, I didn't type that right.
539.
Thanks, bud. 539 plus 539 plus 900h. All that still over h. Whew. Hey, Mar! Look what you said, plus 539. Does that make me happy? That's huge, you guys. That has to happen, and it will happen. Boom, boom. Does everything else have an h? Oh, well, couldn't I actually combine these h's? What is 900h minus 154h? 746. Yep, I got that too. So the limit, as h approaches 0, is we'd have 746 minus 11h. Does that sound right if I got rid of my h's? H, H, H. And I'm left with 746. Hey, Mar, if I plug in a 0 for h, I'd have 746 minus 11 times 0. Final answer?
746.
You got it. Feet per minute is what her, that's exactly how fast Amina's helicopter was rising at t equals 7. And that was a little faster than the average that we had found, which was 625.